Multi-agent systems are the default flex of 2026. Spin up a team of agents, give them roles, and watch the magic. But here is the finding that should give you pause. A team at Berkeley ran a careful study of 7 popular multi-agent frameworks across more than 200 tasks, and the headline is blunt. Despite all the enthusiasm, the performance gains of multi-agent systems over a single agent are often minimal. That doesn't mean multi-agent is useless. It means the upside is smaller and more conditional than the hype implies, and the costs are very real. So before you reach for a swarm, ask the question that gets skipped. What does this actually cost me, and is the payoff worth it? Let's quantify the first tax, tokens. Anthropic published how they built their own multi-agent research system, and the number is striking. It uses about 15 times more tokens than a normal chat. 15 times. But the deeper finding is the one that reframes everything. In their analysis, token usage by itself explained 80% of the variance in performance. Read that again. Most of the benefit of the multi-agent system wasn't some emergent intelligence from agents collaborating. It was simply that the architecture spent enough tokens to grind through the problem. That is a profound and slightly deflating result. A lot of what looks like multi-agent magic is really just a 15 times bigger compute bill in a trench coat. The second tax is reliability. When researchers actually read the transcripts of failed multi-agent runs, they build the first empirical taxonomy of how these systems break. They call it MAST, and they found 14 distinct failure modes grouped into 3 families. First is system design, vague or broken specifications of who does what. The second and the most unique multi-agent is inter-agent misalignment, agents misunderstanding each other, dropping context, or confidently acting on a teammate's mistake. The third is task verification. Nobody actually checks the final result. Here is the point. Every one of these is a failure mode a single agent cannot have because there is no other agent to misalign with. By adding agents, you don't just add capability, you add entirely new ways to be wrong, and the Inter-Annotator Agreement of 0.88 says these failures are real and repeatable, not noise. Now, the fair counterpoint, because this is not a hit piece on multi-agent. The same Anthropic system that cost 15 times the tokens also outperformed a single Claude Opus agent by 90.2% on their internal research evaluation. That is a huge win. So when does the tax pay for itself? When the task is large, genuinely parallelizable, and valuable enough that spending 15 times the tokens is obviously worth it. Think deep research, competitive intelligence, broad literature review, where you want many independent threads pulled at once. The mental model is simple. Multi-agent is a lever that converts money into capability. On a high-value parallel problem, that's a great trade. The mistake is pulling the lever when the task is neither. And here is where the tax is a bad deal. Straight from Anthropic's own engineers, not from critics. Multi-agent is a poor fit for any task where all the agents need to share the same context, because you end up paying to copy that context into every agent's window and to reconcile their overlapping work. It's a poor fit for tasks with many dependencies between steps because today's agents are not yet good at coordinating and delegating to each other in real time. A dependency becomes a game of telephone. And they call out coding specifically. Most coding tasks have far fewer truly parallelizable pieces than research does. So a swarm of coding agents mostly steps on its own feet. If your problem looks like that, shared context, tight dependencies, sequential logic, the swarm is paying 15 times tokens to underperform one focused agent. So what do you do instead when you still want more than one model can give you a loan? The answer the field is converging on is smarter routing, not more bodies. Sakana's conductor, the orchestrator behind Fugu, which we covered in the last video, was explicitly shown to beat expensive multi-agent baselines like mixture of agents at a fraction of the cost. That's the whole lesson in one sentence. A single, well-chosen model or one good learned router that calls the right specialist will often match a hand-built swarm for a small fraction of the tokens and a fraction of the failure modes. Multi-agent should be the thing you graduate to when you've proven you need it, An optimization you justify with numbers, not the default architecture you reach for because it's fashionable. Let's turn the whole argument into a number. This harness runs the same task two ways. The run function models the cost. Each agent is one model call with its own context, so 5 agents means roughly 5 times the tokens of 1. The measure function just records the tokens and the latency for a given number of agents and prints them. So single agent and multi-agent are compared on the exact same task, apples to apples. And the last line is the entire video in one print statement, the multi-agent tax, the ratio of tokens you're now paying. In Anthropic's real system, that ratio was about 15 times. So before you ship a swarm, measure the multiplier on your own task and ask the only question that matters. Is the result actually 15 times better? If not, you just found your architecture.